Welcome to our video tutorial here on expanding and condensing logarithms. In this first example, we want to take this log and write it as the sum or difference of several logs. So first of all, we are going to be basing this on a major log property, which is the log of a quotient is the difference of the logs. Also, the log of a product is the sum of the logs. So as we discussed in class, when the expressions are up in the numerator, they are going to have positive coefficients outside of the log. So when we split this up, this is going to be the log of 5 to the x plus the log of x minus 4 being squared plus the log of the square root of x minus 2 plus the log of the sixth root of x plus 1. That's from the numerator. But then remember, if there's an expression in the denominator inside of a log, you end up subtracting that log. So this will be minus log of 100 minus the log of x cubed minus the log of x minus the log of x plus 5 to the fourth. Notice, by the way, if there isn't a parenthesis around that log of x, inherently what that means is this log of x is a term in and of itself. Ideally, it's nice to put the parentheses around the logs. Now we will invoke our exponent property and pull the exponents outside of these logs. So this will be x log of 5 plus 2 log of x minus 4 plus, now remember, square root as an exponent is 1/2, so this will be 1/2 log of x minus 2. Sixth root would be 1/6, that's our exponent, 1/6 log of x plus 1 minus, the log of 100 is 2 because 10 squared is 100. Then we have minus 3 log of x minus the log of x minus 4 log x plus 5. Now, if this were a problem on a quiz or a test, there's one more simplification that can be done here, so be careful with it. Actually, did you catch the one little mistake? Because I did put one mistake in here to see if you would catch on to it. Giving you a second to catch it. The mistake is in this term right here. What's the mistake? Well, watch out, because we have a log and a log. So really, when you're writing this out, be careful. That's an easy thing to overlook. This needs to be the log of the log of x. So watch for that when we have that double log scenario happening. Same deal over here then when we write our final answer. From a simplification standpoint, it's minus the log of x. And then just make sure that there are no common expressions that we can combine. So here we have a log of 5, x minus 4, x minus 2. I don't see anything in common. We cannot combine a log of x with a log of x. So our final answer would be this expression right here. Please watch for that log of a log issue, though. It's something key to keep in mind. Other problem is going to be, can we take a bunch of logs and condense it into a single log? Now, one disclaimer, it has to be the same base. If it's not the same base, you cannot condense it into a single log. And as we look here, we do have a same base. It's log base 5, log base 5, log base 5, log base 5, but this other item needs to be written in a log base 5 expression. So 3 is the log base 5 of what? Let me come over on the side here. 3 is the log base 5 of what? Well, if we rewrote this, this means that x is going to be 5 cubed, or x is going to be 125. So this will be the log base 5 of 125 for this value of 3. Now when we go to put this expression into a single log, we're going to be mindful of exponents. So this is log base 5, and we could even write it as 5 cubed. Depending on the problem, it might be specific. We will leave it as 125. Minus, this term would be log base 5 of the square root of x, because this really has a coefficient of 1/2. 1/2 as an exponent is the square root of x. Then we have minus log base 5 of 2 to the x over 5. Plus, we will have log base 5 of x minus 1 to the 4th, again bringing the coefficient inside as an exponent. And this is really a coefficient of 1/4. 1/4 would really be the 4th root, in this case of x plus 3. Now when we combine into a single log, we're going to have a numerator and a denominator. Any item that has a positive coefficient will go in our numerator. So the 125 will go in the numerator. The x minus 1 to the 4th will go in our numerator. And the 4th root of x plus 3 also goes in our numerator. Denominator would be anything that has a negative coefficient. So when we're looking for our denominator, it's going to consist of two terms in this problem: the square root of x and then 2 to the x over 5. Now, it's debatable. You could write that 2 to the x over 5, or that's the same as saying the 5th root of 2 to the x. Unless I'm super clear in the directions, either of those forms would be acceptable on that kind of an answer. Notice we have consolidated all of that expression initially into a single log based on positive coefficients end up in the numerator, negative coefficients end up in the denominator, and the coefficients themselves become the exponents of the item inside of the log. Taking those things one at a time, expanding or condensing logs really is not that difficult once you get the hang of it.